As we mentioned in the beginning, today we will check the latest version of the artillery Sidewinder X1. Back in January of 2019, we were the first YouTube channel to publish the assembly and review of this printer. Since that video was published, the manufacturer implemented several changes to the machine while keeping the same Sidewinder X1 name. There has been, however, some changes with the brand name, and the artillery is also known as Rive Novo.
Hey you guys, this is Rui. But before we go through each and every single modification, let's first check what's inside the box and assemble the printer. As the first version, this one comes perfectly packed. With this new version, we have the same user manuals and some extra ones with some explanations in detail. At the side, we have again this nice bag with parts, the power cord, and spool holder pieces. Inside the bag, we have the USB cable, screws and Allen keys, several spare parts, spare flat cables, a wrench, and a USB flash drive. The spares included are a couple of zip ties, a PTFE tube, an RGB LED, a couple of wheels, and a nozzle. Okay, this is everything that came inside the package. And this is the bottom half of the printer. The cooling fan on this one is bigger and located at the bottom. To access the electronics, we need to open the bottom panel. The power supply is a 24 volts and 8.5 amp model. Next to it, we can see the solid-state relay that controls the AC heat pad. At the corner, we can see the display and the memory card and flash drive slots. The board is an 8-bit MKS Gen L equipped with 5 replaceable AT2100 drivers. These are silent drivers, and in Marlin you can define these as TMCs 2100. For the Z-axis, and since this machine has dual Z motors, it has independent drivers for each motor. And this is the top half. At the front, we can see the print head. It's a direct drive setup with a Volcano type hot end and Titan extruder. All the connections to the print head are done with flat cables. These provide a much cleaner look and nicer cable management. At the back side, we can see the dual Z assembly, and at the back of the Z carriages, we see an old ham type setup. At the top, we can see both lead screws constrained with top bearings and synced between each other with the belt. Before we proceed with the assembly, we can start by cutting out the zip ties that secure the axis. And then also remove all the tape that secure the connectors. At the sides, we can see where we need to attach the top half. So let's do exactly that. This time the cutouts are a bit tight, so we need to carefully insert the vertical profiles in. To secure the top half, we need 4 M5x40 screws. You also need to use washers with these screws. Carefully turn the printer on its side, and then use a couple of screws to secure the top half. Do the same for the other side. The top half also has some bits of tape, so take them out as well. Now let's connect everything. On this version, the Z end stop comes already installed, so we only need to connect it. Next is the right Z stepper motor. Then the left Z stepper motor. And the filament runout sensor. Also at the left, we connect the X-axis stepper motor. And the flat cable that connects everything from the top half down to the board. Make sure the flat cable is correctly inserted. To access the print head, we need to remove 2 screws at the side. You don't need to do this if you just want to assemble the printer. Here you can see the extruder stepper motor and the small LED light. So, back to the assembly. Take the remaining flat cable and connect it in the print head. Again, make sure it's correctly inserted. On the first printer, these flat cable connectors had locks that you had to push to lock the flat cable. In this new version, they don't have these locks, so we only need to push the flat cable all the way in. This change was probably made to make things easier for the user. Next is the spool holder. The one with the filament sensor is installed at the left side. From the back side, align the nuts and install the spool holder piece. Use the couple of small M5 screws to secure it. Take the cable and connect it to the filament runout sensor. This spool holder was designed so that we could adjust the width according to the spool we want to use. So we need to take that into account and secure the other part of the spool holder. Okay, and the assembly is now complete. And this is how the machine looks like. The print volume of the Sidewinder is 300 by 300 by 400 millimeters. For more details on this printer, you can see our first video, so check the link of it in the video description. The end stops, and like on the first version, are all electronic. Before we can print, we need to go through some adjustments. For the initial adjustments, we need to check the wheel's grip. The printer has wheels on all 3 axes, but only some of them are adjustable. You can adjust the grip by turning the eccentric nuts. For the X-axis, the adjustable wheel is the bottom one. On the Y-axis, the carriage has 6 wheels, and you adjust the 3 wheels at the right side. And for the Z, you adjust the inner wheels. The wheel's grip adjustment is very important and needs to be done correctly, because too much grip will make the wheels deform, and too loose will make the carriage wobble. We have a video that explains the best method on how to correctly adjust the wheels, so Check the link below in the video description and check it out. Next, we need to check the X and Y axis belt's tension. To adjust the X axis belt, we need to loosen the screws that secure the idler, pull it the necessary amount so that the belt is correctly tensioned, and retighten the screws. Same thing for the Y-axis belt, but for this one, we need to loosen these two screws on the front plate and adjust it. Okay, now we can connect the power cord and turn on the printer. The menus are very simple. In Tools, we can heat up the bed and nozzle. In Extrude, we can push or pull filament. In Move, we can move all the axes. In Home, we can home each axis or all at once. In Level, it moves the print head to each corner to help level the bed. In Change, we can change the filament. And in More, we can turn on the LED near the nozzle and select its color. If we click on Set, we have File where we can select which input we want to use, the memory card or flash drive. Then we have a button with the artillery logo, and in here we have Wi-Fi information, although there is no Wi-Fi module included. Then we have Fan where we can turn on and off the layer cooling fan, and in About we can see the printer type and version. The Continue button is for print resume, and the M-Off button will turn off the stepper motors. Okay, before we can level the bed, let's make sure that the nozzle will not hit the glass. So, manually move the print head to the center of the bed and then lower the Z by rotating the coupling. Make sure the nozzle does not touch the glass in the process. If it does, turn the bed knobs to lower the bed. Stop when it reaches the Z end stop and you will see the small red light. Then carefully move the print head around, always making sure the nozzle does not reach the bed. Next, heat up the bed up to 60 degrees C. And then go to leveling and select the first leveling point. Use a 0.1 mm thick piece of paper and adjust the leveling knobs until you feel the nozzle touching the paper. Move to the next corner and repeat the process. Repeat as many times as needed until all four corners are perfectly leveled. Then go to the center and check the flatness of the glass. Okay, you can now load some filament and run some test prints. The extruder grip adjustment is done by this small knob. This one is difficult to reach and wasn't improved from the first version. In the flash drive, you can find a demo cube already sliced by artillery. Now, let's talk a bit about all the changes between this version that we tested today and the first one that we tested a while back. The leveling of the bed was not an easy job on the first version because of the very small leveling knobs. The new knobs are a bit bigger now, but since the bed is too close to the enclosure, it didn't become that much easier. The location of the flat cable that connects all the wires from the top half down to the board was relocated to a better position. The fan that cools down the electronics on the first version is a small one located at the left side. On this new version, this fan was replaced with a much bigger one, and it's now located at the bottom. The display on the old version is not flushed with the enclosure, while this new one is. Also, the new one includes a reset button. On the Z carriage plates, the new version now includes this old ham type setup. This is designed to eliminate any wobble from the lead screws. On our first version, the print head cover was a 3D printed piece. Now, this cover is made from injection molded plastic, which looks a lot nicer. The previous version used flexible couplings and metal support mounts for the Z stepper motor, while the new version uses rigid couplings and plastic support mounts for the Z stepper motors. The cutout for the memory card slot and flash drive are nicer on this new version. On the first version, the glass on the bed was a smooth one, and now we have a glass with a coating on top. On the first version, we mentioned the fact that a strain relief was missing and was needed for the heat bed cable. On this new version, there is still no strain relief, but instead, they used a bit of heat shrink tube to avoid twisting of the cable near the bed. As for the difference in spare parts, with the first version we had 5 wheels without bearings and a crappy wrench. This new version has a much nicer wrench and a couple of complete wheels. Oh, and a spare nozzle too. One more thing that they added in this new version is a sock for the heat block. As far as print results, on our first review, we noticed that the print quality was okay except for the uneven layer lines that were very noticeable. We ran the same test on this new version, and we can clearly see that the quality has improved. You need, however, to calibrate correctly your extruder and flow or multiplier in your slicer. We have found that with this printer, we need to use a much lower flow or multiplier value, such as 90% or even a bit lower than that, depending on the slicer. Regarding the noise, both versions are very quiet. On one hand, thanks to the silent drivers, but also to the fans that don't make almost any noise. Even the bigger cooling fan under the printer is pretty quiet. And that's it, you guys. Feel free to share your experiences and comments down below. Thanks for watching.